Hello guys, so welcome back to the channel. So today we're going to be looking at this sample enterprise environment that we have here, and there are several things that we are going to be looking at today. So we'll see how to set up our internal environment like this for redundancy, and equally we'll set up SD-WAN with dual ISPs in this environment. So having that being said, let's just take a look at the design and what we have here. So in this environment, as I already mentioned, we'll be setting up SD-WAN at this point here for our WAN environment. And also we have our two core switches that are going to be in the active standby mode as well. We equally do have our two FortiGate firewalls. One is going to be the primary and the other is going to be the secondary, as we are going to set up here. So in this environment we have here, it's a collapse core because we don't have a distribution environment, since we have our two core switches that are directly connected to our access switches directly from here. So alongside this lab, we're going to be seeing how to implement redundancy to ensure that we have no single point of failure. In the case where one particular device goes down, definitely there's always going to be a secondary to take over and ensure that traffic goes through the environment smoothly. So we are equally going to see how to implement EtherChannel as well for higher bandwidth and throughput. We'll see how to make that happen as well, and we'll create all our VLANs and equally different protocols as necessary. So with that being said, let's see how to get along and make that happen. So at the level of our core switches here, there are several things we can do to make sure that one core switch is the primary and the other is the secondary, or rather we can just even we can use OSPF rather to run our internal environment so that it runs smoothly without one switch needing to be the primary or the other being the secondary. But we'll see how to do that with one switch being the primary and the other being the secondary, using things like protocols like there's the VRRP, or you can use VRRP is non-Cisco proprietary. That means you can use it on non-Cisco devices. And also we have the HSRP, that's the hot standby router protocol, which is Cisco proprietary. So we'll be using HSRP, but the procedure is equally so same for VRRP for redundancy, and we'll create all our different VLANs and equally see how to make that happen in this environment. So we'll see how to make that happen, and with that being said, let's just get straight to it and make it work then. So based on our environment here, we'll just start up by setting up our core switches and then our access switches. Then when we are done with that, then we are going to get to our FortiGate environment that we have here as well. So I'll clear the drawings here, and also one key note, we normally expect that internet access from the internet, let's say ISP WAN is the one that's active, is a primary, it gets to our switch here. Our switch receives that if this FortiGate device is the primary security and the device we have for inspection, then traffic is going to be sent to it. Otherwise, it's going to be sent to this other FortiGate device here. And likewise, if this core switch is primary, definitely from FortiGate here, everything will be sent here. And if this is the one that's primary, from this FortiGate, everything will be sent here as well. And likewise for this, if it is the primary, it should have access here like this. And also within our internal environment that we equally have here from our core switch, the same thing applies. If you have that a core switch 1 is primary, definitely you'll have access to our internal environment. And also if this core switch 3 here or core switch 2 is primary, then it's going to be able to have access to our internal environment as well. So connectivity is going to go smoothly. One final thing I'm going to mention is for the packet flow, we are going to be equally setting up SVIs for Inter-VLAN routing, and also we'll see how to make sure that the network connectivity from our core switch to our FortiGate firewalls here is equally done seamlessly as well. So we'll go through it step by step, and I'm equally going to explain what's happening as we progress along. So starting at the level of our core switch here, we'll just create all our VLANs. We have for this environment, we just have 4 VLANs, where VLAN 99 is going to be for management, and we have our different VLANs which you can assign them different names as our departments demand. So Having all that being said, we'll just go straight to our environment here. I'll open our node, and once it's ready, let me just clear this, clear the join. So just hold on for it to boot up, and once it's ready, then we are going to be good to go. I'm going to increase the font, the appearance. So I'm just going to keep it a size of 16, take OK. And I'm going to apply that. All right. So these are core switch here. Hopefully it's visible enough. I think I'm going to increase it again. So let me change that. So we'll just continue with this. And within this environment we have here, we'll just get into our Cisco switch. I'll just hit to click on enable. And once we are there, let me take this to the top. We'll just go to the configuration terminal. And once we are in here, we'll just get along to giving our device a host name. I'll just give it a host name. And I'll just call switch 1. And I'll hit enter on that. So when that is done, the next thing that I want to do is we want to be able to set up our different VLANs at the level of this core switch. Now, with VLANs, you can always use a protocol called VTP. It's the VLAN trunking protocol. In one of my previous videos, we made a video on that where we can use VTP to be able to make sure that all the VLANs that are created at the level of maybe whatever switch which is going to be acting as a server can be synchronized to all other switches in the network. So you can use the VTP protocol to do that. So now, based on this environment here, we'll just continue with what we have. I'll create the VLANs manually, and with that, let's just get straight to it. So here now, we'll just go with our first VLAN. I'll create the VLAN 10, and I'll give it the name as we'll give it the name as users, for instance here. And the next thing is we'll go to VLAN 20, and I'll give it a name as, I'll just give it a name. So give it a name, I'll just give it a name as HR, and also we'll create VLAN 30. I'll give it a name as well. I can just say finance, a finance department, and we equally create another VLAN 99. I'll hit enter here for management. So we'll do that, we'll just give it a name, just give it a name as MGMT for management. So having that been done, the next thing that we're then supposed to do is we use the command or exit this. And having that been done, if you use the command show VLAN brief, we take the command do show VLAN brief. Should be able to see all our VLANs that we created here. So now, with this being done, with the understanding as to how inter-VLAN routing work, hopefully most of us understand. If you don't understand how inter-VLAN routing work, we expect that traffic from, let's say, VLAN 30 to be able to get to this our access switch here. Since we are going to make this port here to be access port, the next thing that is going to happen is when you make this port access port, or let's say this particular port access an access port specific to VLAN 30, it makes this device to be in VLAN 30. And now, since we have these two interfaces that are going to be connected to the core switches respectively, like this next core switch here, these ports here have to be trunked so that they carry multiple VLAN dark traffic to these core switches. So when, let's say, a packet from VLAN 30 gets to our access switch here, let's say the destination was intended for VLAN 20, the access switch here on access switch 1 is not directly connected to that network. So the main tendency is to drop the packet. But since it actually has an interface that has been trunked, it's going to forward it to that particular interface here. So once it forwards it to this switch here, this switch will look at it and see that, oh, because we'll set up SVIs at the level of the core switch 4. When this core switch sees that, oh, the destination is for another VLAN, since it's going to be acting as a gateway to the different VLANs that will be set up, then it's going to know how to forward it to that device, and you forward it through this interface, which is going to be trunk and the likes of that. So once it comes to this access switch here, the access switch, since it operates at layer 2 of the OSI model, you'll know how to forward the packets to the intended PC since it's directly connected to them. So it's good to know that that's for inter-VLAN routing. And for routing to the internet, we'll see about that when we start setting things up here. So we just set up SVI at the level of our core switch there. And to set that up, we are going to be doing that with the hot standby router protocol as well as we move together. So now, having that being said, we'll just get straight here and we'll go to the first VLAN int, enter the interface VLAN 10, and once we are here, we'll do IP add following our IP structure here. This is VLAN 10 here. We'll do IP add and we'll put the IP address here. Now take note, we'll put 192.168.1.1.2, which is going to be the gateway for this. But since we are going to be setting up HSRP, we'll just give it an IP of 192.168.1.2, and we'll put the subnet max 255.255.255.0. Hit enter. Now, once we do that, to set up HSRP, we'll just put standby IP, and this standby IP, we'll just give it a tag standby 1 IP like that, and then I'll give an IP address 192.168.1.1. This is going to be the floating IP that is going to be independent of, let's say, whatever core switch that's available. So this particular IP is going to be set up on both core switches here. Individually on each SVI, here we are going to have IP at 192.168.1.2 on this particular core switch, but on the other core switch, we'll do the same thing with IP at 192.168.1.3, but the standby IP with this ID number will maintain. So that's going to be what is going to be placed there for redundancy. This IP address is not fixed to a particular core switch, so note that, and it's unique for that particular VLAN. So we hit that, and we hit enter. We equally put standby 1 priority, and the priority value here, the device with the higher priority becomes the primary device. So just put here, I'll put 150, and I'll equally put standby 1, and I'm going to equally put preempt. So the reason for using preempt here is to make sure that if this primary device goes down, once it comes back up, it can take the role of the primary core switch as well. So put standby 1 preempt, you hit enter there, and here I'm going to take no shutdown. So I'll do this sequence of commands we have just done here. We'll do the same thing for all the different VLANs, but now having different standby IDs and equally the different IP addresses matching the different networks. So having that been done, we'll enter the next interface. I'll put int VLAN 20, we hit enter. We'll take IP add. We'll take IP add. For VLAN 20, we can see from our network design here, we have 192.2.0. We put 2.2 here, put our subnet max. We hit enter. Oh, I think we need to enter int VLAN 20. Yes, then now I think we can be able to put that. The IP add 192.168.2.2 and the subnet max. We hit enter. Open our standby IP. We put standby 2. I'll just put the this for a different network, and I will put now the floating IP for this network 192.168.2.1. We hit enter. Standby 2 priority. We'll give it a higher priority of 150 and we'll put standby 2 preempt. We hit enter there and we'll take no shutdown. To bring that interface up as well. The next thing we'll do is we'll do the same thing for VLAN 30 as well. We'll do int VLAN 30. We hit enter there and we'll take IP add 192.168.1.3.2 255.255.255.0. Put our subnet max. That's for VLAN 30. We hit enter, and now we're going to put standby 3 IP, and the IP of 192.168.3.1. We hit enter there. This is going to be the gateway for all internal devices within that network. So after doing that, we'll put the standby 3 priority, and the priority value we'll put here is 150, and we'll put the standby 3 preempt. Hit enter there, I'll take no shutdown. So that's that, and the last one is going to be for VLAN 99. For VLAN 99 here. For VLAN 99, I'm going to go to int VLAN 99, and once we do that, we're just going to hit the IP at put 192.168.99.2 subnet max. Then we are equally going to take the standby IP, standby, just put 9 IP, we put the IP address 192.168.99.1, standby 9, I put 9 here, priority values put 150, and standby 9, we'll put preempt, and the preempt value that we are going to, we just leave the preempt like that, as we explained earlier on. So after being done, I just take no shutdown to make sure that interface comes up as well there. So now if I hit exit here, and we take do show VLAN brief, we realize that these are VLANs are there. I think what if we take do show IP interface brief, we realize that all our SVIs are created, but they are down at the moment, even though we're taking no shutdown. Now, they are all going to come up when we trunk these 2 interfaces here, since they are normally going to be carrying VLAN traffic, both for the request, if let's say a device in VLAN 30 requests to access a device in VLAN 20, the packet is going to come to this switch. Since this interface here is trunked, we are going to trunk it. These 2 interfaces need to be trunked, because at one point this one is going to be the primary or the secondary, and this one will be the primary. So this link, if there's no link to this other device, if this is the primary, then all packets will keep fading. So we need to make sure that we'll have both links to the 2 core switches. So when the packet gets to this core switch, what's going to happen is that if we don't trunk this interface here, packets will never be able to get here for the different VLAN packets that are destined for any of these networks here. So that's why we will need to trunk these 2 interfaces, and the response from this device as well. If this interface is not trunk, then packets destined for VLAN 30 is not going to go through. So that's why we need that as well. So now, with that being done, we just need to enter these our 2 interfaces, G0/2 and G0/3, and trunk those interfaces. So we'll just do an interface range, and we'll go to GI 0/2 put a column like that to 3, so we can set them up as well. So you just do the switch port trunk encapsulation dot one cure. We'll do that, and we'll do switch port mode trunk. So now when you're actually trunking interfaces like this, by default there's something called the native VLAN, and all by default the native VLAN on all switches, Cisco switches, is VLAN 1, and sometimes you might want to change that as well. But in this environment, we'll leave it. Probably as we progress, we'll find time and come and change the native VLAN. It's good. It's a security mechanism as well that you need. So now after that's done here, you can want to permit certain VLAN traffic to go through this trunk port, or you can allow all VLAN traffic to go through. By default, so you can see that SVI interface are just all coming up right now since those interfaces were trunk. So by default, you realize that when you just do the switch port mode trunk, all VLAN, all the different VLAN traffics are normally by default allowed to go through those particular interfaces, except otherwise that you want to explicitly, let's say, permit some defined VLAN traffic to go through that. So now you can see that HSRP is coming up, and you can see that the state standby is currently on the active state at the moment. When we set up the secondary, then things will start going through properly at that point there. So now, with that being said, we are just going to go after doing the trunk on those interfaces. I'll just hit here. I'll take note shutdown as well on this our range interfaces here. And one final thing before we leave here is, if we look closely, we are going to set up EtherChannel here, and on these two interfaces here like this. We need to make them, because with the way FortiGate actually works here, maybe we're going to do this when we start setting up FortiGate, so we can understand how packets leaving from our internal environment going to the internet work all together. But let's just finish setting up our core switch and equally setting up this secondary core switch as well. So now, with that being done, the next thing that I want to set is our EtherChannel here. We'll just come to this our two interfaces, G1/1 and G1/0. So we're just going to set up these two interfaces for EtherChannel. Then we'll explain about that as we progress. So we use exit here, and we'll do the int range. We'll enter as a range. If we enter as a range, and we'll do GI1/1, comma, you can use the range or you can take them manually. 1/0, I believe it's same. Let's cross check that. GI1/1 and GI, yeah, okay, 1/0 is fine. We can bundle that together. And when we take that range, we want to set up, let's say, EtherChannel there. We'll just start by channel group. We can give it a group as maybe group 1, group 10, or whatever number you choose, but make sure you use the same thing on the other side. And we'll set mode here, and then we're just going to set it to active here. So depending on what you're trying to configure, the type of EtherChannel you're trying to set up, there's lab and there's Spark as well. So one is Cisco proprietary, while the other one is non-Cisco proprietary. So it's always good to go with the one that is non-Cisco proprietary. But if you're setting up Cisco devices, then you can just go with any of them, because any of them can be set up on the Cisco devices that you have. So now with the channel group 1 mode active, if you set this state here to be active, then on the other side as well, you can either use, if you're depending on whatever EtherChannel you're trying to set up, you can use, maybe there's active, and there's passive, there's desirable, and there's auto as well. So you can use any other methods you want. You can, if I type here passive, you see it's going to come up. If you type here active, you see you have an option. If you type here, for instance, desirable, you see you have an option. And if you type here auto rather, yes, you have an option. But in this case, we'll just go to active, so that each member is going to be actively trying to make sure that the EtherChannel is established between both members. So if you just use active here, make sure on the other side as well, you can use active, there's no problem, or any other option available there specific to what type of EtherChannel you're trying to set up, be it whether it's lab or pack. So now we'll have channel group 1 mode active. We hit enter there, and we'll have a virtual interface that's created. I'll just trunk these two interfaces as well. I'll just do switch port trunk encapsulation.1 cure, and we're equally going to do the switch port um, mode trunk. We'll do that, and once we do that, the next thing that we want to do is I'll just take a no shutdown here. After this, if I take do show IP interface brief, we're going to see clearly that once you set up your EtherChannel like that, you equally have a new port channel. This is like a virtual interface here that you have now, and it's currently down. So now we'll go into it. I'll exit this range here. I'll exit, and I'll take int port channel 1. That's what we did. And I'll just do, first of all, I'll trunk this interface as well. We'll do the switch port trunk encapsulation.1 cure, and I'll do switch port mode trunk. We'll do the switch port mode trunk, and I'll take no shutdown. So now it's currently still going to be down because it's going to be waiting for the other core switch to come up. So having done that, we are not yet done with the setup here. Once we are here as well, we are going to set these two interfaces as well, and we'll see how to do that. So coming back here on this our core switch 4 that we have here, which is like the core switch 1 we have, we're also going to set up IP routing available because it's going to be performing routing functionality. So we hit exit here and we take IP routing, that's necessary, and we can equally create a default route as well. We'll create a default route here to point to our FortiGate firewall that's going to be here. But before doing that, I want us to be done with this internal environment, and then we'll see how to set seamless traffic flow from our core switch to our FortiGate firewalls as well, which is equally very important. So now, after doing this, I'll just take do write memory to save our configurations. We are then going to move to our core switch 3 here. Open that, and we'll set it up as well. So I'm just going to increase the font size. So we'll do that, and wait for it to come up here. So once it comes up, we'll just as usual click on enable, and we'll go to the config terminal. So once we are here, we'll give our device a host name. As that host name, we can just give call switch 2, and we hit enter there. So our host name has been given, and we'll do the same thing. We'll create our different VLANs as well. VLAN 10, give it a name as users. The next one is going to be VLAN 20. We'll give it we'll give a name as HR. And the next one is going to be VLAN 30. We'll give it a name as finance. The next one is going to be VLAN 99. We'll give it a name as MGMT. We hit enter there. So once we do that, the next thing we want to do is to set up SVI as well now. And this is where the secondary part is going to come to play. So I'll exit this, and now we're going to do, we'll go to int VLAN 10, add our IP addresses, but now we'll see where the trick comes in. So we'll do int VLAN 10, we'll enter there, and from our design that we already have, you can see VLAN 10 has this network as we're doing on the other core switch. So if we enter VLAN 10 and we take IP add, we'll put the same 192.168.1.3. On core switch 1, it was actually 192.168.1.2. Here we'll put .1.3, we'll put our subnet mask, .0, and here we'll put the standby 1. Make sure it matches what was on the other core switch. Now we put the IP here, the same IP address 192.168.1.1. Hit enter, and also you can then be able to set up the standby 1 priority. So now we're going to give it a lower priority on this side. We'll give it a priority as 100. So it becomes the secondary, the one on standby. And also we are going to put the standby 1 preamps as well. We hit enter there. So we'll do the same thing for all our server VLANs. At least by now we get the whole concept. So we'll do int VLAN 20. And then we're equally going to do the same thing. IP app 192. And we'll hit enter. And here we'll just stand by. So IP .2.1, we hit enter there. And here we're just going to put a standby. So priority, we'll put 100 and put a standby 2 preamps. We hit enter there. The next thing we take no shot as well. The next thing we're going to do is, I think I didn't take no shot on VLAN. No problem, we'll work on that as well. I think I didn't take no shot on VLAN 10. Yes. The next one will enter into VLAN 30. And we're going to take the IP app, put our IP address. One 192.168.1.3.3, 255.255.255.0. Hit enter, and then we're equally going to take the standby 1, standby 3. This is for VLAN 30. Priority IP rather. We'll put our IP .3.1. Hit enter, and we'll equally put the standby 3, and we'll put priority. We'll put 100. We'll put the standby 3. Preempt. Take no shutdown. We'll do the same thing for VLAN 99. So int VLAN 99. So if we take int VLAN 99, we can already clearly see that we just give some time. I think we received one of the messages already. You can see once we set up VLAN 30 here, you can already clearly see that here we're having the hot standby 5 state change. So VLAN 20 group 2, we're equally getting all the messages now already at the bottom. For VLAN 30 that we just set up, you can see the state group 3 state change to active here. Not that this is the active device we're going to work on. We're going to see that as well. This one is not the primary. We'll see the primary once we are done with the setup. So we're currently inside VLAN 99 here. And to just confirm, I'll just do int VLAN 99. And we'll do the same thing, IP app, we'll do 192.168.99.3. Yes. Yes, we'll do that. Subnet max. And we are going to take standby 9. This group ID has to match, and we are going to take the IP 192.168.99.1. This has to be unique, and we are equally going to take standby 9 priority 100. Take the standby 9 preempt. We hit enter, we take no shutdown as well. We equally do int VLAN 10. I think we didn't take no shutdown here. I'll take no shut here as well. So we need to make that interface come up. So once we do that, we'll just give it some time, and we're going to see what we have just done so far come to life. So from here, we can all just clearly see that if you come to the primary one, the primary FortiGate, the primary core switch we had, you realize that here, if you use the standby show brief, the show standby brief, you will get that, okay, these are different interfaces, and you can see the different groups, and also the priority 150, which is for the primary. And also here at the secondary here, you can see the same thing here, the priority is 100. So this is going to be like the backup for all those different networks on both core switches here. So before we complete the setup for this our core switch 3, which is like the core switch 2 that we have, we are going to get in there and then set up. Remember, we partially set up the EtherChannel for these two interfaces on core switch 4. We are going to go to core switch 3 and complete that setup on these two interfaces here as well. So to do that, I'll go back to the config terminal mode. We'll do int range, and those two interfaces are G0/ should be 1/0 to 1. Enter that, and when we do that, the next thing we'll just do channel group put 1, we'll put mode, you can set to active as well. We hit enter, and here I'll just do switch port trunk encapsulation.1 cure, and I'll do switch port mode trunk. I'll trunk those interfaces. And when that is done, I'll just take no shot. If I take exit here, we'll enter now the virtual port channel that has been created here. That's a virtual interface as well for the EtherChannel setup. We'll do the int, and I'll go to port channel 1. And once we are in there, the next thing is I'll trunk this interface as well. It's not mandatory, but I'll do it. So I'll just do int. We'll do the int VLAN. We'll do int VLAN for instance. Yeah, let's see. We'll do, let's see, int. Yes, we just need to do switch port. Switch port. Let's see. Yes, or enter the interface. And we'll do switch port trunk encapsulation.1 cure. We enter, and then switch port mode trunk, and we'll take no shutdown. We'll take no shutdown then. So with that being done, EtherChannel is set, and all our SVR interfaces are already set. And what's left for us to do on this other switch here is to trunk these two interfaces here leading to our internal environment. So that's G0/2 and G0/3. So I'll do that. I'll just enter the range, int range G0/2 to 3. I'll enter that, and I'll do switch port trunk encapsulation.1 cure first, then switch port mode trunk, and then I'll take no shutdown. That needs to be done. like that there, as we explained earlier why it has to. So now, once that is done, I'll just hit on exit here, and we'll just check key things here. So we'll check or hit exit again. We'll check our hot standby router state. We'll just put the show standby brief. You can see that the current state here is standby. It's no longer active. Before this was active, but now the state is standby. And if we go now to our core switch here on switch 4, we hit enter here, and if we check here, show standby brief, here should be active because it has a higher priority value. And you see the standby devices, and you equally see the virtual IP addresses. And that's how you can set that up. So now the gateway for all devices will be these virtual IPs depending on their networks, and also here as well, the virtual IPs are equally here. So regardless as to whether this core switch goes down or this other one is up, the virtual IPs are on both environments to make sure that connectivity is seamless. So having that been done, we're just going to move to, I'm going to save the configurations that we have done here on our core switch 3, write memory. We'll just save our configurations first. After doing that, we'll move to, or let's see, I don't think we checked our EtherChannel summary. I'll just wait for that to be saved, and we'll check the EtherChannel summary. Let me check here. Show EtherChannel summary. You can hit that, and we should be able to see, yes, everything looks fine. The group 1 protocol we're using is lab, and equally we'll see our ports that we are bundled up together and the likes of that. So that's port channel 1. So it's good, everything looks fine, and we are good at the moment here. I'll equally save what we have done here as well. Write memory. So we save everything there. The next thing we want to set up is, currently we have set up our core switch environment, but we are not done, because remember we have these two interfaces that we need to set up here. Because I'll explain why I kept this here. We'll see the technique that we can use to make sure that these are two FortiGates actually connect seamlessly with our core environment. There are several ways you can do it, and since we have two links, if we had just one link to each FortiGate without two links, you can just set up an IP address on each interface so that this switch performs routing functionality as it's already doing. But in this case, we're just going to set up a VLAN and put these two interfaces, since these networks and these networks will be same. But we are going to get to it shortly. So having that been done, we'll just get to our access switches here. And I'll clear this here. So coming to this access switch, we're just going to go into it, and once we are there, I'll double click on that, open it up. I equally change the settings as well. So once we are here, I'll hit enter. I'll just go to enable conf and here as well, we'll just put in the setup that we need. And here I'll just give it the host name. I'll give it the host name as, I'll just say access 1. And as it's already explained already, once we are inside here, first of all, we'll just create the different VLANs and then assign them as necessary. So I'll just create the different VLANs as before. VLAN 10, we'll give it a name as users. There is VLAN 20. That's for VLAN 20 there. We'll hit enter. We'll just give it some time there. So that's VLAN 20. I'll hit enter there and I'll give it a name. And the name here we're going to give is HR. We'll create VLAN 30. We'll give it a name, finance. We'll create VLAN 99. We'll give it a name as MGMT for management. So I hit exit here. So once we are done with that, the next thing is we just have to trunk these our interfaces that we have here. And within these two interfaces, you can permit specific VLANs you want. You must not permit all VLAN access within this or to go out of this switch. And if you don't want all VLAN based packets to come to this switch, then you can restrict that at this interface here. But from these interfaces, when we're performing the trunking activities, we just permitted all VLAN access. So for security purposes, depending on your environment, you can just restrict VLAN access as it suits your needs. So now we'll just go to this our two interfaces first. Our access interfaces, we'll do int VLAN 1/0 interface rather int giga ethernet 1/0. We'll do switch port mode access and switch port access. We'll put VLAN, that should be VLAN 30. We hit enter there. And once you do that, the next thing is you can just leave. But there are some security tips I would like to explain here concerning things like STP and equally things like BPDU guard as well. So now, whenever you have your environment like this set up and you're about to set up an access port, what happens is the switch always uses some few seconds to try to understand if the device that's trying to connect through that interface is another switch or is an endpoint device. So in order to actually improve or reduce latency, you can just ensure that that time is not applied to that switch. The switch does not use that duration of time to find out whether it's another switch that's available here. So you can implement that using the spanning tree port fast command, and also you can use the BPDU guard. And for you set up BPDU guard because you don't want a scenario where you set up this interface to be a port fast, like to be a port fast interface, as we just explained earlier, and then someone still brings a switch and connects to this port here. You want a security mechanism where that interface shuts down automatically. So that's what BPDU guard does. So now we just set up the switch. It's going to be spanning tree port fast, and then you set up spanning tree BPDU guard enable. So you want to set on that interface. So that's what we do. I'll exit here and I'll enter the next interface G0/2. Is here 0/2. And here we'll do the same thing. We'll do switch port mode access, switch port access, VLAN. So it's 99. We hit enter there. And we'll now do spanning tree port fast, and we equally do port fast, and we equally do spanning tree. We equally do spanning tree, and we'll do BPDU enable. Take no shot here as well. No shutdown. We'll do that. And after doing that, the next thing we just want to do is we'll come to these two interfaces here and trunk them as we explained. So we'll do int range. I'll just enter range and we'll put GI 0/0 to 1. And we'll do switch port mode trunk. No, I should be switch port trunk encapsulation.1 here first, and then switch port mode trunk to trunk them together. And then now you can do the switch port trunk allowed VLANs will just be allowing VLAN 10. So that's VLAN 30, comma, and I'll put 99 as well. So do that. I'll take no shutdown to bring it up as well. And with that being done, we're temporarily done with the access switch here. So we'll do that. Remember, since we have not set any IP address on this access switch, so it's impossible for this access switch to be able to reach, for traffic to be generated from this access switch to get to any other device. But if you want to put an IP address, since we have already created a management VLAN, you can be able to do that by just entering int VLAN 1 and then, or maybe int VLAN 99 on this switch, and put a unique IP address from the VLAN 99 management network to make it happen. So that's what you can do. I'll just hit exit here for now. And when I do that, the next thing is we want to just go to our other core access switch. I'll just open this as well. And once that is open, I'll try to increase the font size. So it's ready. We'll do the same thing, enable configuration terminal. And once we are here, we'll just give it the host name. I'll just give it access dash switch 2. So hit enter there. And once that is ready, so host name has been set. We'll just create our VLANs here again. Remember, we've been creating all the VLANs manually. In order not to create them manually, as I said at the beginning, you can use VCP, and it's going to automatically synchronize VLANs within the network as needed. So with that being said, we'll just go to VLAN 10. I'll give it a name as users, VLAN 20. I'll give it a name as HR VLAN 30. We'll give it a name as finance and VLAN 99. We'll give it a name as MGMT. So when that is done, I'll just hit on exit here. We'll just go through the same process as we did on the first access switch. We'll just set up our access interfaces to suit the specific networks and do the same thing. So do int gi 0/2, and here we'll just do the switch port mode access and switch port access VLAN. This is 20, and we'll do the same thing. Spanning tree port fast enabled, so it's just spanning tree port fast. And then the next one is going to be spanning tree BPDU guard enable. So enable that. I'll take no shutdown here. And we're going to enter the next interface, int gi 0/3, and we'll do the same thing. Switch port mode access, switch port access VLAN 10, and switch port. Yes, that's okay. And then we'll just do the spanning tree port fast, and we'll do spanning tree BPDU guard. BPDU guard enabled. take no shutdown, and when we are done, that's going to be good. The next thing is we want to trunk our uplink interfaces 0/0 and 0/1. So just take int range g 0/0 to 1. Hit enter there, do switch port mode, switch port trunk rather, switch port trunk encapsulation.1 cure, and the switch port mode trunk. And then once you do that, you can then put switch port mode allowed VLANs, switch port trunk rather, trunk allowed VLANs. You can put VLAN 10 here and 20, since those are the two VLANs within this environment. So those are the two we are going to permit. And yes, so once we do that, we are going to be good. And aside that, that's how we are going to be able to make things work here. So when that is all done, before we start going towards our firewall, we can just test for connectivity. I'll power on one of these our lightweight pieces here. I'll just power them on for now, and we'll just set some sample IP addresses within them to see. I'll save what we have done here by do right mem, and let's check our other access switch. I'll save what we have done here too, do right mem. So we'll save our configurations there first, and once that is done, we can then try to test for connectivity. So I'll just put a test IP address on this device within this network, which is 192.168.1.10, and here I'll put 192.168.3.30. So I'll just double click that, I'll open, and then once it comes up here, I'll just give it an IP, which is 192.168.10.1.10 rather, .1.10 with the subnet marks, and we're equally going to give it its gateway, which should be the virtual IP at the level of our core switch, 192.168.2.1.1. That should be it. You hit enter there and you take save. So I'm equally going to go to this our next virtual PC here. I'm going to add an IP address there, IP 192.168.3 and give .30 here /24 and put its gateway 192.168.3.1, which should be the virtual IP at the level of the SVI here. We hit enter, and then we take on save. Yeah. So we'll do that now. We can just try to test for connectivity. I'll try to increase the font size of this. So now, since we have that, we'll just try to do a ping from VLAN 30 to VLAN 20 to see if it's possible. So if I do a ping, for instance, 192.168.1.10, which was the IP that we set. So let's see if it can go through. Good. So it shows traffic from VLAN 30 to VLAN 10 is possible. And if we use trace, and if we try to ping, if you use trace 192.168.1.10, you see that it hits the SVI first. This is the SVI gateway here. This is the gateway that it hits before getting to the end device per se. So it's good to know that like that. So the virtual IP is still very functional, and to test to make sure that everything is working for Inter-VLAN routing here, I'm just going to power off this our core switch since we have saved what we did there. I'll stop it, and then since it's stopped, I'll just do a continuous ping on this side -t. We'll do a continuous ping to see if it's possible. Let's see how long it's going to take before core switch 2 comes up. You see it's still going through. As you can see, we have just stopped this core, a primary core switch, and you can see we still have access to this environment here. Like that is going. So that's how you can make sure that SVI is running and there's redundancy available between your two core switches that will be distributing those different access traffics. So I'll just stop these pins for now. And with that being done, we're just going to now try to see how to start progressing ahead to see how to set up connectivity. How do you want connectivity to flow from a core switch to our FortiGate devices? First of all, we must understand the networking here and how FortiGate works in HA mode. So now, since we're going to be trying to set up, we're going to be setting up the active HA, that's the high availability setup here. It's good to know that one particular firewall, the firewall acting as the primary firewall, is going to synchronize most of its configurations and its database information with the secondary. Even interface configurations that are going to be synchronized with the secondary. So what do we mean? Initially, if you just set up, if you configure a particular port on FortiGate, let's say we have this single FortiGate here, Fortinet 1. If we set up this port here, maybe it's with DHCP, this other port here is DHCP, and we set up this interfaces here. Since we already know that by default, all the different interfaces on a firewall or let's say a router represent different networks. So this network here is different from this network here. These are two different networks. So now what happens is during the failover, the primary FortiGate, the IP addresses on this interface that are going to superimpose on the IP address on this interface here as well. If this is port, let me clear that. So if this is port 5, here on port 5, the IP address that was here is going to come here. And similarly, port 6 is going to equally come here as well. It's going to override that which was here. So it's good to take note of that when with this setup we are trying to do. So now it shows this network here and this network coming to this FortiGate have to be same, to be on same network. So that's why we're going to create a VLAN here and equally just put a gateway there so that both these two devices here will have access to that single network. And the same thing is going to happen here. Another new VLAN will be created here to bundle these two interfaces here to have another different network, as we can see, so that we'll have a different network connecting here and we'll have the same network connecting here rather. So hopefully that makes sense. It's good to understand that logic before we go ahead. So now to make that really work, I'll just power on to make that really work, we'll just power on our core switch. I'll just start it. And while it's coming up, this is the network here already been set. These are the two networks by design. I'll just go to core switch TV, I'll open it, and then I'll create a VLAN, and then I'm going to give it an IP address in this network, which is 172.168. I'll open this. Oh, let me see. Yeah, I think it should be okay this way. So, which is going to be in this network, and then let me close this. Okay. Then we'll have switch TV available here. So now, yes, EtherChannel got down because I switched off this other interface, but it's going to be coming up shortly. So now, based on what we have, we just need to, at the level of this here, I'll just come here, I'll create a new VLAN, I'll hit enable on that core switch 2, go to conft, I'll create VLAN, for instance, create VLAN I'll give a name like VLAN 100. Here, I'll give it a name, and the name is going to be just say fort, and I'll give it as fort 1 or fort 2 rather. Let me just use fort 1. We'll give it that name, and I'll exit. And once we are done with the VLAN, we'll just create, I'll just shift this to the top. Yeah. Yes, so we can see clearly. So once we are here, we're just going to go to int VLAN 100. First of all, the thing we need to do is we'll put an IP address there. We'll do IP add, and we'll put just 172.1.6. It's not going to be HSRP is not going to be set up on this interface, so it's just going to be the normal IP address set on the VLAN interface there. 172.1.6.2.1. We'll put that there like that. Put our subnet marks of 255.255.255.0. You can use /22 if you want to. /30 rather. That's for point-to-point links. I'll hit enter there, and I'll just take no shutdown. That's the first thing that we'll do. And when that is done, so VLAN is up. We'll go now to core switch 4 here. I'll open it all back. Since I stopped it, everything stopped. So I'll change the settings again. So we'll change the settings and wait for our core switch to come up. So I think it was still loading. So just wait for it to load and come up good before we proceed. So once everything is done, we'll do the same thing, and then we'll bundle these two networks, these two links, because they'll be connecting same networks together. So we'll just do the same thing there, and once it's all ready, we'll see how to make it work. So having that been done, we'll just hit enable, and we'll go to the configuration terminal. So once we go to the configuration terminal here, you see since we brought it back up, this switch has turned back to be the active switch. So it's important to note that. So now once we are here, we'll just do int VLAN. We'll create another different VLAN. I'll create VLAN 200, and I'll give it the name as fort 1. Yes, we'll just do that. Let's see. I'll give it a name. We'll give it a name as I think I've not created the VLAN. I'll just hit exit. VLAN 200. We'll give it a name fort 1, and I'll exit. And when we exit, we're just going to add this IP address here, this network 172.168.1.1. So this is going to be like whenever FortiGate wants to access internal environments, they'll forward their packets here to 1.1. So that will be the internal route that we're going to set there when we are working with the FortiGate firewall. So we'll do int VLAN 200. And then we're going to add now the IP address on that interface, which is 172.16.1.1. Put our subnet marks. We need to use IP add. We need to use IP add there. We need to use IP add, and I'll just take no shutdown. So that's being done. I'll just take do write memory as well. So it's now up. So now one of the final things we need to do here, because we need to understand how packets need to flow within this environment. So for traffic flow, a user from VLAN 10 wants to hit the internet. Traffic normally has to reach the access switch. Using this strong interface, it gets to the core switch. The core switch sees that it wants to go to another network that it does not know, because currently this core switch here with the SVIs, it knows VLAN 20, 99, and VLAN 10, but it's not directly connected to the internet. So we must set up a default route inside here that would tell this particular core switch that, okay, if your destination is to reach probably the internet, forward it to this interface of FortiGate here, which is going to be .2. Now the question remains like, okay, what if maybe this device is not the primary and this one is the primary? The default route is pointing here. Do we not need another route to point here? No, because when this one becomes the secondary, the IP address that was here automatically override the IP address here. So that same IP will be valid if this one is active for the core switch to forward it to it. So you just send to 172.168.1.2 and automatically the IP address will be here as well. Since during the failover in HA mode, that's the active standby, during the failover, the IP addresses on these interfaces will override those on these other interfaces. So that's what is going to happen. And also from FortiGate here, we'll need a default route to point. We'll see how to set up SD-WAN to really optimize WAN traffic. We'll see how to do that so that everything works smoothly as well. So now we'll just set the default route here, and let's see, let me come back here. We'll set that default route up, and to set it up, we'll just hit exit here. We'll put IP route. The destination is, for instance, 0.0.0.0. That's anywhere with the subnet max of anywhere as well. Forward it to 172.168.1.1.2. That's going to be our FortiGate uplink interface here. .1.2, since it's going to be there. So this is what we're going to do at this core switch 4. But on core switch 3, we'll tell core switch 3 to send it instead to 172.168.2.2, since it's going to be the link here. And if the failover happens here, it's no longer going to be .3, it will be .2. So initially, when you're setting things up, you don't even necessarily need to set up, let's say you need the IP address temporarily here. Let's say if our management, because our management PC is going to be here, where we'll try to use the GUI to be able to set this up. There are other methods by which you can do that. So we'll just use this current method here just for management purpose. But you realize that when the failover happens, you'll just be using the primary IP address to set up both environments. So we'll just do that IP route. The destination is 0.0. You should forward it to that here. And I'll just take do write memory. Now we'll go to our other core switch here. This is it, core switch 3. And once we are here, we'll just exit as well. And we'll do IP route. If the destination is anywhere, 0.0.0.0, with the subnet max of, forward it to 172.168.2.2. Hopefully it makes sense now. You can hit enter there, and I'll just do write memory. So that's what we have to do at that point. So now minimizing that and going ahead. So with that being said, we'll just power on our FortiGate devices. I'll just power them on, and we'll set them up as well. So I'll just power this and equally this as well. I equally power this other FortiGate device. And once they're booted, what we'll just need to do is we'll just have to go and set up these two interfaces. We'll set up these interfaces here as such, and we equally set up these interfaces. We'll make the interfaces to have management functionalities, and we'll also see how to set up HA We'll use the CLI. You can use the graphical user interface if that fits you. It's equally fine as well. We'll set up this our other two interfaces to be DHCP based, and we'll set up networking as well, because we need to tell the FortiGate, you need to create the routes on one device, because if you want to access, we need to create the routes on two devices even, because here we need to create a route. There's going to be a default route pointing to the internet, and there should be equally be a specific route to access our internal environment, where, because we'll be trying to access the GUI from here. So we'll have to tell this FortiGate, this Fortinet 2, we'll have to tell it that, okay, if you want to access devices within the, like this our VLAN 99 piece here, forward the packets to this interface here of the core switch. We'll have two routes here. You can use this or this here. It's very possible for you to use that. Or if on this FortiGate device as well, you can also be able to use, for instance, you can use this link here, or you can decide to go through this part, or you can decide to go through this part. It's up to you depending on what is active. But we need two routes inside here. Since we know this is the current active one, we'll just put one route to just forward everything here, and also here we'll forward everything here for now. So that's what we'll do, but we'll see how to make things really active as well from there. I'll just clear this and then we progress ahead. So once they're coming up, I'll open them, and this FortiGate one, we're going to change the appearance, the settings of what's available, so it becomes visible. I'll change that to 18. Click OK. Now apply. So when that is done, I'll just hit enter there. Hopefully it's still booting. I'll just double click on Fortinet 2 as well. I'll bring that this way, and we are going to change the settings too. And we'll go to appearance. I'll change here. I'll go to 18. Click OK. Click apply. So now we'll just wait for them to be done booting. This Fortinet 2. We'll start with Fortinet 1. So we'll just wait for the boot to be complete, and then once it's done, we'll get in and we'll start the configs. All right, so once our FortiGate is done booting, we'll just hit the default is always admin with no password. So we'll be prompted to put in a new password, enter that, or confirm again. And once that is confirmed, then we are logged in now. So once we are logged in, we'll just try to set up at least the hostname, config, system, global, and we'll just put hostname, set host name, and we'll just give it a name like FortiPrim. Just give it a name like that, and then we'll just hit N, and the configuration should be saved here. So now the key things we need to note here: by default, a firewall is just, of course, an advanced router, which normally has a lot of security functionality. So with the FortiGate firewall is equally a next generation firewall that offers all those features. So now, by default, the policy within the FortiGate firewall is set to drop all traffic. So we're just going to set up a policy that's just going to accept to permit all traffic flow from internal to external, equally from external to internal temporarily for the setup, but we'll change that as we progress as well. So to set that on the CLI, I'll just go to, you can always type in config firewall, config firewall, let's see, let's just see firewall. Oh, we need to first go to the configuration mode. So we'll just proceed by setting up our interfaces first. We'll set up port 5 with the IP addresses corresponding to the networks as we said. So this network here, within these two links here, we'll be going, hope that we get it clear. This is going to be the network for this link, and equally for this link as well here. we need these two networks. I think let me put it at the center here. Let me put it close to this core switch, so see from here it's the same network, and let me just shift this close here as well. So this links leaving the core switch to these respective FortiGate firewalls at these networks, and from here likewise. So we'll just go back here, and we're just going to set that up as well. So we'll just hit config system interface. We'll hit that, and then we're just going to go to edit, just go to one for instance, and we're just going to edit set port 5 rather. So we'll just set our interface. So we set interface, and we'll just set port, that's going to be port 5. Port 5, we hit enter, and here we're just going to put an IP. We just put set IP. We'll do that. So we'll just set our IP address as we explained, which is going to be 172.168.1.2. Put our subnet marks to match. We hit enter there. We're equally going to set allowance. The allowance here is the allow access. Since we want to use this port for management as well, we can just always use you can actually, for ping, you want to be able to ping it, you can set for the different access you need depending on your environment. Not all access has to be given. For security purposes, just always use the least privilege access, give access just as needed. So these are the different types of options that you can give out there. And also we are going to now use we're equally going to set, you can set the role, you can set the device type, you can set the mode to static, and the likes of that. So there are several things you can do when you're done with that, then you can just hit on end. So let's see. Okay, let's just try to, okay, I think the default VDOM should be the root VDOM. Let's go back. I'll just config system interface. We'll edit port 1. I think it should be port 5. We'll get there. And then we're just going to set the IP. We'll set the IP, which is going to be 172.16.1.2. Put a slider there. We're equally going to set allowance, the allow access rather, which is going to be, we'll set give ping access, HTTP, SSH. We'll give HTTPS, and yeah, you can just give the list you need. And then here I'll just take end. You can give an alias, you can equally give a role to the interface as you need, but I'll just take end here for now. Rather, I would have taken next. But we're just able to config system interface. We equally want to edit port 6. Edit port 6. We hit enter here. And here we're just going to set IP. And the IP address that we are going to set there for this other network here, since it's this interface here is .2 for this other network, which is 172.16.2.0, the 2.1, the 2.2 rather, 172.16.2.2. Put our slider, we hit enter. We're equally going to set allow access to just give ping, give HTTPS, and the necessary permissions and protocols needed for management. So we hit enter there. I'll just take next. So once we do that, the next interface that I want to set up is this, our DHCP based interface. We have port 1 and we have port 3. So we're just going to go there. We'll just say edit port 1. We hit enter there. And we're just going to set IP to set mode. I'll just set mode to DHCP. Yes, we'll just set the mode like that. I'll equally set allowance to, I'll just give, we don't want to give any access here. Just keep it the way it is. We don't want to give management interface on our one interface. So that's temporarily for now. Depending, sometimes you might want to set up access on the management interface, but depending on your environment, you have to be very careful with that, because if not well done, you're just increasing your attack surface. So with that being done, I'll just click on next. Here we'll just edit port. The next port is to set is here is the next port is going to be port 3, I believe. Yes. Edit port 3. You probably just set the mode to DHCP as well. And with that being done, we should be, I'll just go to next as well here. The next thing to do is I'll just exit here. I'll take N rather. So we'll save that. The next thing to do after setting up all our interfaces as we have done on the CLI is to set up the router the static route. So we'll just config router static. We'll just edit, let's say our first entry 1. I'm just going to set destination. If it's headed to anything that begins with 1, let's say 192.168.0.0, I'll just put /16. Since this our internal environment, everything begins with 192, I'll just summarize that. I'll just set the destination as this. I'm going to equally set equally the device, because it always needs an interface here. We're just going to say set device, and we'll put the interface. Interface here is going to be, is we want it, I'll just say use port 5. When it gets here, you use port 5. If it's here, you use port 5 to get there. So that's one thing we're going to do for you to be able to access that environment there. So use port 5 to go there. So put port 5. Oh, I hit enter, and that should be it. I'm equally going to set the gateway, and the gateway now, since we are currently on this our Fortinet one, the gateway to get to this internal environment should be through that SVR here. On this device, we set it to the VLAN. Here was, I think here was 100, here was 200. So it should be, that gateway should be 172.16.1.1 as we set already there. Hit enter. This is a key trick to make that work. So once we do that, the next thing we're just going to do is to just end. We can end the setup here. So that's it for the route. And for the route facing the internet, our ISP, since it's going to get an IP automatically, is going to be assigned a default route to point to the internet as well. So that's going to be fine. And we'll just minimize this, and then we're going to go straight to the next Fortinet tool to just set things up from there. So I'll just power on this our admin PC here. So while it's coming up, we should be done setting up FortiGate, the second FortiGate as well. So we'll just enter here with our default credentials, admin, and we'll put in, just hit enter, set up a password, admin1 should be complex. Here we'll go to config, system, global, we'll set the host name, and the host name we can give here is 41. I think it should be 40. Secondly, I'll just put 40 sec, and I'll just take end. So it takes effect. The next thing we want to do is we want to be able to also set up the different interfaces as we did before, which is just temporal because it's going to be overridden. So on this device here, I'm just going to set up just one interface here, and which is going to be our port 5 interface, because that's what we need. When HA setup is going to override port 6 to be set up automatically. So to do that, what's just going to happen here is I'm going to say what's going to happen here is we can just set up config system interface. So once that is done, we are then going to move and set up our, once that is done, we'll just set up config. Here we are just going to set things up like, we'll just set up our interface, we'll just edit port 5, we can edit port 5. We're just going to set, you can set the mode to static, and then you can set the IP address, you can set the IP as a network here designs. So here port 5 should 172.168.1.3. We'll just do that. 172.168.1.3. Put the slider /24. We hit enter. Locally set allow access. You can set in ping, HTTPS, SSH, and the likes of that. But don't always give full access, just give what you need in that environment. And also here, you can give some alias, you can equally give some, you can set some roles as well. So I'll just hit end here to save that. So now the reason for me even trying to set up a management interface here is if you want to use the GUI to set up HA, then you need both to access both devices. But the thing is, in this case, we can set up HA directly on the CLI, and it's equally much preferable that way. So now before going to set up HA, I just want to make sure that we set up a firewall policy on both devices to just permit all traffic from either whatever interface that we are working with, and we are going to reconfigure it later. We're just going to go, and this is the second FortiGate here. I don't need to even configure the policies on this secondary FortiGate. I'll just configure it on the primary, and when we set up HA is going to, all the configurations on the primary will be set. Not all, majority of the configurations on the primary that are going to be synchronized to the secondary. So we'll just config firewall. So I'll just hit here, and while we're here, I'll just go to config. Let me see. So to make that happen, we'll just config firewall policy, and we'll edit, let's say 1. Let me just show and see what we have here. So currently there's no firewall policy, so edit and put our first entry. So we'll put in that, and wait for it to come up. So once it's up here, what we have to do is we'll just put the source interface. So we'll just set source interface, for instance, probably any. Let me see, I think source interface should be any. Destination interface, we'll set it to any as well. We are equally going to set source address, source, yeah, I think we need to set source address to all. Set destination address to all. We're equally going to set action to accept, and we're equally going to set the schedule set to always. We are going to set status, we just enable. We're equally going to set, I think, NAT. We just enable NAT to be available. Yes, I'm going to set NAT. We enable NAT there, and NAT is going to be applied to one facing interface faces. And then I think set service, yes, it's important as well. We'll just set all services. Yes, we just set all services, and for login, let's see, set log traffic. We just see UTM, that's for Unified Threat Management, if it's actually set. But just put that temporarily, and from there we should be able to end that. I'll end that, and yeah, if everything goes well, it should save it. So by default, we're just going to permit all traffic through the firewall. Temporarily, we're going to set up SD-WAN and set up our rules as needed. So now, with that being said, I don't need to set this on the Fortinet 2. That's our secondary security. That's our secondary firewall, because once it synchronizes all these configurations, they're actually going to be implemented there as well. What we need to do now is to set up HA. So to set up HA, there are several things we need to do, and there are several things we need to note, especially at the level of the CLI. The interfaces here, as we need to set up our interfaces, and equally set up if we want the active passive or the active state. So in this case, we're just going to go the active passive, where one is going to be active and the other is going to be the secondary. So that's what we are going to do here. So now, with that being said, let's get straight. So to set up HA, the commands are quite basic. You need to come to your primary FortiGate, and within your primary FortiGate, first of all, this is where we just had to make sure that by default on the primary FortiGate, we just had to make sure all traffic is allowed through the firewall by default. That's just temporal. And to set up HA on the primary, the first thing you need to do is to config system HA. You need to set the mode to active passive. Then you set the group name here, as we just did. Equally set the group ID to 1. And then now you set the heartbeat interfaces as on the topology. If you look on the topology, you realize that we have port 2 and port 4, which we designed to be for our heartbeat. And the heartbeat is very important because that's the interface that the secondary uses to check if the primary is still up, and if it realizes that it's down, definitely it takes the role to be the primary and keeps forwarding packets as necessary. So that's what you need to do, and you need to enable session pickup enable, so that, for instance, for session pickup, why that is important is if a user in VLAN 30 was, let's say, had traffic that was scanned through the firewall to reach the internet. What if they return the response from that same traffic gets to this firewall when the firewall is down? Does it mean that this secondary FortiGate will drop it? No. So with session pickup, it actually synchronizes the session table as well to make sure that all sessions are in sync with one another. Now you equally do the session override enable. So this is the command that makes it possible for all the configurations on the interfaces here, equally the policies, to override the current policies that are available on this secondary FortiGate as well. Equally the routes, equally the interface configurations that we set there. So that's what we need to do on the primary. You can take note of these primary configurations, and then you take N. For the priority, we'll give it a higher priority of 255, so that it becomes a primary. So if you get now to the secondary here, so these are secondary FortiGate that we set up here. And for the secondary FortiGate, you realize that on the CLI is just the same thing as well, where to set that up, you go to config system HA, you put in the mode, it must match. The group name also has to match. The group ID has to match as well. Our heartbeat interfaces, session pickup is enabled, session override enabled, and we have a lower priority, and we can end the session. So HA is set, and so secondary starts to sync and the likes of that. So for instance, here we can clearly see that this was how the synchronization was happening. They say here we have the confirmation: secondary succeeds to sync to external files with primary. Secondary file is not in sync with primaries and the likes of that. So just give it some time, all the synchronization will be done if you have the commands as on the slide, as on the video you can see here. So now we're just going to go now we're going to use, we're just going to come to this our sample. We're going to go to our admin PC, and within our admin PC, we'll try now to access this our firewall and try to see how to set things up at the level of the graphical user interface. So I'm just going to click this here, and once it comes up, then we are going to log in, set our IP, and then try to access the browser from here. So let's give it some time, and we should be good to go. So once we are here, we'll just put in our password to log into our Windows device. I'll just put in that and we'll log in. And once we are in, then I'll just try to expand this, and I'll try to minimize that, so you have the full view of what's happening. So once that comes up, what we then have to do is, first of all, we just need to set up our IP address and make sure this device is in VLAN 99. I'll just right click here, and then we'll just set an IP address on it. So once we are here, we'll just set it up. We'll set our IP address, equally set our gateway, which is going to be 192.168.99.1. Should point to the SVI. For DNS, we'll not use DNS for now, so we'll just hit OK here, and I'll just hit on OK as well, and that should be good. So once it's ready, then we are just going to move to the browser. I'll close this too, so that from here we'll move to our browser and try to see how to access our device on the CLI. So just give it some time. I'm equally going to close this link too. So once that is done, we'll just open our browser. I'll just open Chrome, and then once it opens, we'll just access that particular IP address on the graphical user on the web UI and see how to proceed with more setups as necessary. So once it's up, we'll just go along, and then we're just going to input the IP address of our FortiGate server there, which is, we'll use HTTP, and with the colon, put in our IP 192, it'll be 172, not 192. Should have 172.16, we have 172.16.1.2. That should be the IP address that we use there. So hit enter on that, and then wait for it to come up. Once it's ready, then we should be able to access the GUI. So currently we are failing to actually access that on the browser, but we'll just try to test for connectivity. I'll come to this our PC here, and once I'm there, I'll just come there to, I think it's PC 9. We'll come down and try to ping that IP address. We'll ping 172.16.1.1. Let's ping that if it's reachable first. Yes, that is good. What about .1.2? Hit enter. So yes, that means it's not going to be accessible. So we'll go back to our FortiGate CLI on the primary FortiGate. We'll get to that primary FortiGate CLI there. I'll log back in with admin, put in the password. I'm going to go to that interface there. I think the mode should be set to static. We'll go to config, system interface, and I'm just going to edit port 5. We expect to edit that on, we expect to access that on port 5. I'll set the mode here to static. equally set the IP address as well to 172.168.172.168.172.1.1.2. Put our subnet mask. We hit enter. I equally set allow access want to be pingable. We are going to use HTTPS, SSH, and so on. Just keep those for now, and I'll take end for now to save the changes. So when that's done, we'll go again to our PC9 again and try to see if that's possible. It should go. We are still getting some time out here. Okay, so let's go to our FortiGate device and try to see if we can even ping the gateway. So this is our FortiGate CLI. We'll just do execute ping. We'll try to see if we can reach 172.168.1.1. Is that possible? We cannot hit the gateway at the level of the core switch here. Within this our core switch, it's impossible. Yeah, I think I know why. Within this our core switch here, we cannot even reach. The pings keeps failing. The reason is because we created the different VLANs here. We created VLAN 200 here, and we equally added an IP address on that VLAN 200, but we never made these two ports to belong to VLAN 200. That's where the problem is. Likewise for these two here. So take note of that. So if we go to core switch 4, I'll just go back here. I'll hit enter. And once we are there, I'll hit enable. We'll do take, for instance, show VLAN brief. Realize that we have our different VLANs here, and there's equally VLAN 200, but you can clearly see that there are no interfaces to it. These are the only VLANs that don't need ports assigned to them, but here we need ports to be assigned to this interface here. So according to our design, you see that we have G0/0 and G0/1 that need to belong to VLAN 100 or VLAN 200. So we just need to do int range. Go to the configuration mode first, conft. I'll we'll do int range gi. Let's see our interfaces again. 0/0 and 0/1. I hit enter. Let me confirm it first again. Yes. Here we just the switch port mode access and switch port access VLAN 200. This was what was lacking, and we can equally do the spanning tree port fast, and can equally do spanning tree BPDU guard. Enabled. And here I'll just take no shutdown, take do right mem. So save that. So now we'll go ahead and test again. We'll try from the FortiGate CLI, our primary FortiGate CLI 41 here. We'll try to do a ping to that. Yes, now we can ping that gateway there. So that's fine. And so also from our PC, our VLAN 30 there, or any VLAN, I'll try to hit that. VLAN 30. That's PC9, yes. PC9 is here. We'll just use the upper arrow to do that same ping. Good. So now we can be able to access it. So now we'll go back to our Windows PC and try to access it on the CLI. So if we come back here, I'll just do a refresh, and everything should work just fine at this point. If all goes well, it should. Good. So once it comes up as it has done now, I'll just take this here to the top. We should be prompted to log in. We'll use our username and password, and once it's done, then we should access the graphical user interface. So just give it some time for it to be ready. All right, so once it comes up, we'll just have to put in our username, which is going to be admin, and we'll go ahead to put in our password. Let me see. So we'll put in our username, which is admin, and then we'll go to our password and put in our password. So put in that, and then once we are done, then just hit for login and wait for it to come up. So once our setup comes, we'll just proceed. I'll just take later here, and let me see. Okay, that's good. Just wait for it to come as well. So once our CLI opens, like as we can access the FortiGate on the GUI, we can see several things already. You can see HA is set up, and this is the primary device as well. And you can also see clearly that there's some few setups that if you want to do, you can be able to do. If I pull this to the top here, there's several things we can be able to do. You can view the HA status from here. I'll just click on HA, and once it's okay, we should be able to see the HA status as it shows us on the graphical user interface here. So just click on HA and give it some time to come up. And once it comes up, then we'll be able to see how that interface looks like. So you see clearly, once it comes up, then you can just clearly see this HA. You see that now these are our two devices, the FortiPrim and FortiSec, and currently FortiPrim is the one that is the primary with higher priority and the likes of that. So you can set up on CLI, or you can be able to set up HA on, you can just set up HA directly on the graphical user interface. It's quite easy to do here, but the thing is there are more available options that you can be able to do at the level of the CLI. So that being done, if you equally go to minimize this, and then we are going to also go to our network interfaces. So once we get to our network interfaces from the setup that we have here, you see that we set up these interfaces to receive IP addresses through DHCP. So I've just powered our switches on. We don't need any configurations there for now, but depending on your environment, you can set it up as necessary. So we'll just wait for it to come up. And once it's ready, we'll come to hit the drop down arrow on network, and then we'll click on network interfaces. And then once it's ready, so when you look at our interfaces that we created, you realize that we have the different interfaces here. We see these are our two interfaces that we created that are already here on the graphical user interface. If you scroll to the top, there you will see that one facing interfaces already have their IP addresses from DHCP, and equally they do have a default route as well. So that's one thing to note. So I'm equally going to try to see how to set up SD-WAN and how to optimize our WAN interfaces for automatic failover in case one interface goes down, the other one comes up automatically. So here we can equally see that that's our DHCP IP address that's given there, and everything looks fine. So if you equally go to static route, you can click on static routes to currently see the routes that are available within this environment, and just wait for it to come up. So if you look at our static route, it seems as though we have just one, it's like we have just one particular static route, which is pointing to our internal environment. But since an IP address was given to us through DHCP, if you go back to the CLI on the primary FortiGate, I'll just put here admin, put admin here. And here, if we actually use the command get router routing, I think the command should be get router routing or the info routing table details. Yes. If you hit enter there, we should be able to see, yes. So you see here we have a static route at the level of the CLI. This is the static route that we need via port 1. Yeah. So you can clearly see that, and then these are the directly connected networks and equally the other static routes or internal environment. So now, having all that being put together, I think we can equally take a look at our firewall policy as well. We'll just give you some time to come up. Or rather, these are the policy routes. Rather, if you want to look at our fire policies, you can come down to policies and object, and then you'll be able to find that there. But now we'll try to set up SD-WAN. But before setting SD-WAN up, there are several key things we can be able to do. We'll try to bundle up these our two interfaces to be at the level of a zone, and then when we are setting up our SD-WAN, then we'll set it up properly then. So we'll go to interfaces here, we'll click on interfaces, and once we come to interfaces here, we'll just go straight to, we'll go to our external facing interfaces. That's I think that's port 1 and port 3. We'll bundle them up to be in a zone. So wait for it to come up as it is right now. And once it's there, what we need to do is we'll just create a new, we'll just come here and click new. Once you click on new, then we'll need to go with the zone. Let's give it some time. You click on zone here. We'll create a new zone. And within that zone, we're going to add those two interfaces there. I'll just put one. So here we'll just give the zone name, and I'll give it a name like one interfaces. So here I'll just leave this like I'll disable this for now. We just want it. If you want to block entire zone, you can do that, but I'm just going to add members to the zone. So I'll just add port 1. Now equally add port 3. So these are going to be the 2, 1 zone members. So just hit on OK, and then once that is done, we'll just have those two within a zone. So now when that is done, the next thing is we want to go to, we'll go to our SD-WAN here, and once we get there, we'll create our SD-WAN zone and equally create the necessary things as needed. So let's just wait for this to be done. So if you look at the bottom here, you can see you have the two interfaces. These are the one interface is here in the zone, port 1 and port 3. Okay, so now the next thing is we'll just head over to SD-WAN. You can click on SD-WAN there and wait for it to come up. So once it's up here, what we need to note here is that we have the SD-WAN rules. We equally have the performance SLAs as well. So we'll see how all of these are really interrelated with each other. It's very important to note that. So we'll first of all start by creating our SD-WAN zones. As here, we'll just come to new here, and then we'll go to zone first before add the zone members. So we'll create the zone first. We'll have by default, we'll have just the virtual WAN link, which is the default zone that's available. So we'll create a new SD-WAN zone, and when we do that, wait for it to come up. So once it's up, then we can just go ahead and give a name to it. I'll just say SD-WAN zone. I'll just give it a name like that, SD-WAN zone. Not SW, but SD. and we'll add the members. You can add the members directly from here. You can hit the plus icon here, and from here, first of all, just close this and I'll take OK. I'll hit the plus sign here. From here, we're just going to create the entries. Or maybe we'll just first of all we'll just hit on OK and add the members later. That'll be fine. So we'll just click the edit SD-WAN member. So edit that, you click here, interface here. You can just hit the drop down arrow. You put your two interfaces. That's going to be things like port 1, output. I think we had port 1, it's not here because we have placed it at the level of the zones. I think we need port 1 and port 3. Let me just hit the drop down arrow here. Which zone do you want this to be in? It's giving us a default. I'll just hit cancel here for now. And once I do that, I'll just create the zone only without the members. We'll just create that for now first. So it's currently down. So while we're here, I'll just double click on this our SD-WAN zone that we just created now. You can click on it and take edit, or you just double click on it. So I'm just going to head back. We did not need the zones. We did not actually need the zones for the interfaces. We needed the SD-WAN zones. So we need to instead close this. I'll just try to click on this here, and we're going to delete this zone and remove the different interfaces from it. So once we have deleted those two interfaces, we have deleted that zone which we created on the interface layer and equally added port 1 and port 3. Once we have deleted that, everything should just be fine. We should then go back to SD-WAN here, and we'll be able to add the SD-WAN members there and see how to progress ahead with that. So just wait for it to come up and then we'll work with it. So once it comes up, here you can then see that this is our SD-WAN zone that we created. You can then click on it. You can click and then hit edit. And once you do that, you have the options now to put both WAN interfaces on that particular zone as WAN members. So as it comes up, we'll just go straight to that as needed. So you can see this is SD-WAN zone. Then you now click on the interface members. Here you can then create that entry. So you take create, and once you do that, it should come up properly, and once it's set, we should be able to set that up. So here, the first thing is we need to choose our interfaces, our interface that we need as a new SD-WAN member. Here, hit the drop down arrow here where it says none. You can click on that, and now you see port 1 is there and equally port 3. So I'll click on port 1. I equally hit the drop down arrow again, and then we're going to take port 3. We need these two things one at a time, no problem. Just go port 1 as it is. So port 1, we want it to belong to what SD-WAN zone, the new SD-WAN zone we created, we'll put that there. And for the gateway, it can be dynamic to whatever is available, since the gateway is a dynamic interface here. So this is the gateway automatically gotten from that interface as well. Here is enabled and priority state is 1. We can allow the default there. Or take OK here, like this. So when that is done, we'll then have to hit the plus sign here to create. We'll just hit this and then we'll create another entry here for the two SD-WAN members. So I'll just hit create here again. We'll create an entry for the other member. So here we'll just hit the drop down arrow. I'll take port 3, and then the default, I'll use the SD-WAN zone here. We'll create we choose our SD-WAN zone and keep the default here like this. We hit OK. So once that is done, we'll have our two entries that need to be available here. So I'm just going to add in the first entry and the second entry here so that they can be part of the members of this SD-WAN zone here. So I hit on OK. So the reason why we're doing this is so that these are our internet facing interfaces. So we won't fail over in case one interface goes down, the other interface comes up and perform the same roles nicely. Now, creating the SD-WAN zones and the members is one thing. As you can see here, if I hit the plus sign at the bottom, we'll see that we have two members available there once it comes up. These are our two members here, and you can see traffic is going through port 1 and the likes of that. But here you can optimize it more by first of all setting up your performance SLAs and equally your SD-WAN rules. So now the performance SLAs here just has to do with the criteria by which you want to check what particular parameters are being put in place to ensure that that one interface is up or down. And if that parameter is used, then at the level of your rules, you can set things up as well. So these are not firewall policies, but they work in line with firewall policies as well. So currently right now, the default policy on our firewall is set to permit all traffic on all interfaces, whether SD-WAN or physical interfaces. But normally in a production environment, it's not going to be the case. You need to make sure you have well-defined policies on all these different interfaces. So we'll just try to set up an SLA, for instance. It could be you have packet loss, there's latency, there's jitter, and the likes of that. So we'll talk about latency today. We'll just get involved with latency. We're going to create a new service SLA, and once we do that, we can create an SD-WAN rule with that SLA to make sure that that particular one is used as needed. So with that being done, we'll just go straight here. I'll click on create new, and once it comes up here, we'll just wait for it to come up. So once our new performance SLA comes up here, we'll have several options. We can give it a name. I'll just give it a name as ping. Let's say ping, for instance, ping SLA. Can give it a name like that. I think maybe using cap locks would be good. So just a ping SLA here, and we have the prop mode. We have the active. This is the active mode. We equally have passive and prefer passive. So I have different here. So now here, if you follow through with what the, let's say, the prop means, if you can always just hover over to read. Active sends prop to determine link quality. Passive use traffic to determine link quality, and we have prefer passive, same as passive mode, but sends prop where there is no new traffic. So with active, what you're trying to say is that you set some parameters as to how this particular server needs to always, let me use underscore. Let me just close that. I think maybe it's not necessary. Yes. So you're always going to use parameters like as we have set to active here. You're always going to tell this particular firewall that okay, always try to reach maybe this particular server. In this case, we'll just try to put Google DNS. So we'll put here 8.8.8.8, and you can add more servers if you want to there, but we'll keep that the way it is. And we're going to say all SD-WAN members, or you can specify SD-WAN members. So you can click on specify here, and then once you take specify, then you can add in your SD-WAN members. So it's good. The prop mode is active. That means it's going to constantly be trying to reach these particular servers that we have, this IP address that we have placed here. For passive, it's going to always use user traffic. If it's reachable, fine, then it knows that link is up. If it's not reachable, then it knows it's down. So we're just going to use this server. That's more ideal. For participants, we'll just go with, we'll click on specify, you hit the plus sign here, and then it should give us the option to add in our two SD-WAN members that we have. So I'll put both, that's port 1 and equally port TV. So that's what we're going to set there. Once that is done, we'll have SLA target. You can hit this if you want to, but in this case, we'll just leave it off as it is. So from here, We have the latency threshold, and we have the jitter threshold. Since we're really working with latency, we can keep the default for now. The status is currently check interval after 500 milliseconds, failure before inactive 5 seconds, and the likes of that. So you can have that all set, and that's the first thing to do that you need to set up. So the next thing that I'm going to do here is we'll just hit on OK. We'll just hit on OK here to save that. So we'll just come here for where it says our SLA targets here. I'll just disable this first. I think we need to enable this. Yes, I'll enable that. And then once it comes up, I'll just disable for jitter and packet loss. I'll just keep latency threshold only for now. If you're working with jitter, you can work with that. So now, after that is done, then you can just take OK then. So I'll click on OK, and then we'll find out how the status looks like. So that's how you can be able to set up your SLA. This is just a parameter that SD-WAN is going to use to find out what particular link is actually active or not. So after doing that, we'll just wait for it to load up. And once it's ready, we'll just go to the bottom and check to see what particular link is preferred over the other. So since this is the parameter that is going to always use. So I'll mute this. So if we come to the bottom here, you can clearly see that this is our ping SLA here, and you can see that via port 1, everything seems to be up via port 1, but via port 3, everything seems to be down because it has not yet obtained an IP address through DHCP yet. So now for the SD-WAN rules, you then need to come to your SD-WAN rules here to create the rules using your ping SLA that you have here. And we'll just wait for that to come, and then once it's ready, we'll see how to make it work then. So if you look at the current SD-WAN rules, we just have SD-WAN has an implicit policy just to allow all traffic, and it's just going to work based on the default criteria that's there as to what internet service provider is up and the likes of that. So I'm just going to create a new SD-WAN rule, and just wait for it to come. Create new, and once we do that, wait for it to come up. So once it comes up, we'll just give it a new name, like we can give any name, maybe can just say best link. Can just give it a name as best link. So if you have some source addresses and the likes of that, you can put them here, or you can keep the defaults here. I'll just put in, if you have some specific source addresses that you want to make sure that traffic leaving from those source addresses going to the internet, the role just matches them, then that's fine. But aside that, here we have everything just pointing. We don't have any address. You can just even put all addresses as you need, or you can put all private addresses. And here you can just put all if you want to, or you can specify some specific groups. I'll click on all. For user groups, if you're using some identity based awareness within your environment like LDAP, or you have users locally, you can put a user group here for those users. For the destination, you can put the destination address as well. I'll just hit the drop down arrow here. I'll wait for it to come up. I'll put all there. Maybe if you want to create the rules for some specific, I'll just put any protocol number there. Maybe if you want to create the rules for some specific applications that you want to, then you can play with that and everything will just be fine here. So for address destination, you can put all or any. Here, it all depends on you. And once you go to the bottom here, you can then equally choose for the outgoing interface. Do you want to manually set things up, or you want to use the best quality link or the lowest cost SLA? So depending on what your environment suits, then you can use that. So I'm just going to go with the best quality link. And here we'll now put in the interface preference that we want. We'll put in our two interfaces here. That's port 1 and port 3. I'm going to add another port here. I'll put in port 3 as well. And also for a zone preference, I hit the drop down here. We'll use our SD-WAN zone. Now required SLA target, you can use the drop down arrow here. And then you can use your ping SLA that we just created. So it's going to use this and ensure that it uses the best. I'll just go to best quality link. I don't want to use maximum bandwidth. We'll use the best quality link. Yes, that's what we are going to use. And we'll put our interface, measured SLA. We hit the drop down arrow here, and then we'll scroll down. We choose our ping SLA. Once we do that, criteria is latency. You can use the drop down arrow to choose whatever option you need, or just choose latency so that you choose the best quality link as regards to latency here. So this is just going to be the rule. I think the SD-WAN rule is quite straightforward, where you can specify other sources, or if you have user groups, you can use that. The destination, you can probably just use the internet here for all access and the likes of that, or you can specify as your environment needs. And then probably if you close this here, let's say you don't want to use bed addresses, maybe if the destination is some specific type of application, let's say I'll go with TCP for instance. Let's say I go with, let me click outside here. So for the source, for the destination, you can hit the plus sign here, and then maybe you just choose, maybe I'll just choose all for now. Or maybe if you want to go with applications, maybe a user is about to go to access a particular application, then you can then use what particular internet service you want them to get to and the likes of that. So all that is possible depending on what you want. So if you use here any, you can work with addresses or with internet services or with applications. Like for instance, if we close this, I'll just close this here, and I'll just click outside here for now, and it's going to reboot, and then we'll see the option to add internet services. So if you, or maybe applications, you can hit the plus sign here to say if the source is any user that wants to access this particular application, like let's say let's load the different applications. It could be maybe Facebook, or maybe Microsoft 365, or whatever service it could be. You can always choose any application of your choice, and you can create a new one, or any application of your choice that's there, or maybe WhatsApp or whatever, and you want to increase the quality of the link which is going to be used to reach that app. Or let me just say, for instance, we have here, let's just use any app. Let's see, Google Analytics, Google Business Apps. Let's see what we have. Let me just say Google Business Apps. We'll just put that there. Let's say anyone wants to get to use Google Business Apps, for instance, here, I'll just click here. You can clearly see that whatever, you can choose the internet service as well. And so we can actually get ahead to create a SD-WAN rule. We'll just give it a name here as best possible link. And equally, the source address, you can specify whatever source address you need. And I'll just click here. Okay, we'll have the best link there. And here we have the source address. You can click on that. And once it comes up, for now, we'll just use all addresses, for instance. So SD-WAN rules are very different from firewall policy rules. It's not like if a rule does not match, then it's going to drop that traffic. No, it's just going to go the default underlay internet access traffic, like just going through whatever ISP link is active. And okay, so if I use all here, for instance, as the source, I'll click on all. If you have some user groups, you can add them here, which specific users you want to use this particular SD-WAN rule. And then for the destination here, you can use an address or you can use an internet service and an application. Like for instance, if you click on application here, we are going to see all other possible applications come up. Maybe it could be Google, it could be maybe whatever application that's over the internet. You can create a sample of that application here using a link and the likes of that. And once it's available here, you just need to add it here and also the internet service that you need. And once you set that, you can then go now to choose the category. So for instance, if we have, let's say Alibaba is here, I'll just click on Alibaba as the application. I'll just click here. And once that comes, I'll just scroll up a bit so we can see. So once we are here, I'll just hit this internet service so we can see the internet service as well. So we can hit the internet service as well there. And we'll just wait for the different internet services to come up so you can choose whatever service you want to use to access Alibaba, for instance. So you can see these are the different services here that you can be able to choose depending on what you need, right? But if it's a little complex, you can just close this and just probably just choose all addresses. So you can hit this the plus sign icon here where it says addresses, and then you choose all addresses as well. So I'll just choose all, and once we do that, I'll click outside here and I'll just close this too. So once we do that, then we should be good to go. So from here, you can use a protocol number or just use any, or you can specify. Now, the next thing to do is you're trying to say if any user is trying to reach any server, that's whatever server that's over the internet, the outgoing interfaces, I'll scroll down here. You want it to measure based on the best quality link. You can use manual setup to assign manual interfaces, but you want it based on what we're trying to do. We want to use the best quality link, and interfaces of preference, we use the plus sign here. Let me see which one I have to click. Wait for it to come. I don't want to choose this. No. So here the interface preference here, you click on that and then you choose your both interfaces that you have. So click on port 1 and port 3. So when that is done, then the zone preference. So hit this drop down arrow here and then you can then choose your SD-WAN zone preference as you need. So let me click on that. I think I did not click. So that's our SD-WAN zone that we created. And when we do that, measured SLA. So we need to use the SLA that we created. So it's just going to try to use ping. This is our SLA here. I'll just go to the bottom here. We have the ping SLA here. So it's always going to try to use both internet links, both WAN facing links to use. You use ping to see to access that 8.8.8 server that we configured. It's just going to try to check, okay, which one is actually more preferable. Even if both of them are up, it's always going to check the one that used less time to arrive the destination to make sure that that's the best link to forward this particular user traffic through and the likes of that. So with that, we can just hit OK and we enable the rule to take effect. So just give some time for it to happen, and that's going to be it. Also, one thing to notice at the level of your firewall policies, you need to make sure that the rule, the source is from, if the source is coming in from an internal port, the destination port, the destination interface there should actually be the SD-WAN interface. Note that. But for this lab, since not to make the lab too long, will just allow all traffic to go through. But in a production environment, you want to make sure you have detailed policies, giving least access as necessary, and also the implicit deny rule at the bottom to make sure that no other person has access. So if you look at our rule, it's just going to load and then we'll see it there. We'll just give it some time as well. So you can clearly see now that this is our rule here, and see the best link. Source is all, destination is all, criteria is latency. You have the port members, and then you can add more functionalities to this list if you want to, and the likes of that. So I'll just try to see. I think we should be able to see more information than this. If you right click here, let me click here, we should be able to see more options here. If I click this filter option, you should be able to see more options available, but it's fine. But these are SD-WAN rule, and you can see the tick is on port 1 because that's the one interface that's really functional at the moment there. So don't forget that the steps you need: you create your SD-WAN zone, you add your members, and then you create your performance SLA, and then use that performance SLA to then create your SD-WAN rule. But with that being done, one final thing that we will, so once it comes up, our SD-WAN members are here. You can clearly see here that for the bandwidth, you try to see that okay, for downloads, everything, port 1 is the one that's active. For upload, you see port 1 is still active because port 3 is down. And then for volume, it's quite different. And for session, it gives us information about what link actually handles the most sessions, in case both of them are even up equally for volume as well. So now, if we go back to our static routes here, we realize that I think we checked already at the CLI, and we saw that although within our static routes, we don't have a default route pointing to the internet, but once DHCP gave our device an IP address, we could see that there was a static route at the level of the CLI. I think if we go to the primary here, we can still see it here. This is it. This is the static route going to the internet. But this is not what we want here. We don't want it to just be going to a single IP address like the gateway here. We want SD-WAN to really perform that functionality. Like here, we can see on the GUI, we have just one route that's going to our internal environment, which we set when we're setting the network up. But here, we are going to create a new static route. And once it comes up, we'll see how that is done. And I think this particular part is important to note as well, that even if you're not setting up SD-WAN rules and SD-WAN policies, then you can always just use this setup. I think it's equally going to help do some optimization for the underlay network as well. So let's just wait for it to come, and then we are going to push with that. So we're just going to create a new static route. So say destination is anywhere. The interface here, you click on the plus sign here, and then you should be able to choose SD-WAN zone. So this now is important here. So when you choose SD-WAN zone, this now automatically does the load balancing and everything necessary that you need. Not load balancing, but equally tries to use whenever one link is down, the failover is automatic rather. So I'll hit OK here, and that should just be fine. So at this point, before even setting up SD-WAN, you should have been able to access the internet already, and our internal environment equally should be able to access the internet because nothing is already happening at the level of our firewall here. So we implemented NAT here, so the default firewall policy has not included. So I'm just going to go back to where we were here, and then we see our route available for WAN optimization. So with that being done, maybe with the VPC, we'll just try to see if we can be able to access. We'll have our two routes there. And with the VPC, that's VPC 9, for instance, we'll try to see if we can access the internet from here. Try to see that, and boom, everything looks just fine and it's working good. So if I do a continuous ping from this VPC, we can all just clearly see that if you come back to SD-WAN here, if you come back to SD-WAN here, you realize that you should be able to give us some information as to what particular link, the amount of the speed, the amount of data going through that as well. So let's wait for it to load up. If I hit the plus icon here, beside is our SD-WAN zone. We can clearly see the amount of data going through this particular port 1. So that's it there. And let's see, you can clearly see there for downloads, uploads, you see everything just looks fine there and the likes of that. So that's how you can set it up. And one thing I think we should look at our policies here. If I hit the drop down arrows on the where it says policy and objects, it's good for us to know how to structure policy. And since the firewall is a stateful firewall, then if you click this, I'll just come to firewall policies here. So we'll just wait for that to come up. So one final thing that I want us to see before we end the lab of today, we're just simply going to see that by default under firewall policies, we have our implicit deny rule, and we equally have a rule here that's permitting all traffic. Normally, you don't want to do this in production. Here, you can just even create a temporal rule to say that, okay, if a device wants to leave from your internal environment, from your internal interface towards your destination interface, the destination interface here should be SD-WAN. That's what you need to specify here. And equally, the destination addresses, depending on how you set it up, can be set to all, or as you suit your needs. And then for services, depending on what service needs to be accessed and the likes of that. So for action, we're accepting NAT is equally going to be implemented here, and we're accepting this policy. So it's good to note that when you're working with SD-WAN as well. So your from interface is going to be from your internal environment, and your destination interface is going to be to the SD-WAN ports and the likes of that. So it's good to have that in mind. I'll just stop this.